How's it going, everybody? I want to welcome everybody back to this learning VMware NSX-T before we actually do an NSXT series kind of thing. So it's actually kind of cool what we're able to actually pull off with this. So what I've done since the last video is I've gone through and I've created some overlay segments that I've pushed from the NSX Manager down to vCenter, and the segments show up inside of vCenter now. I then mapped I've created a number of additional Linux VMs. They're just lightweight Ubuntu. I think that's how you say it. 1604 LTS VMs with VMware tools installed. And once that's all in place, I then deployed a Tier 1 gateway and attached the segments, the overlay segments, to the Tier 1 gateway. And then I deployed a Tier 0 gateway and configured an external interface on it to connect up to my CSR 1000V, which is my logical or my software top of rack switch or top of rack device. Then I connected the Tier 0 to Tier 1 gateway together, and then I went into the networking and I made sure to do all the route advertisements on the NSXT side, and then I did some configuration on the CSR 1000V to allow it to work. So I have a eBGP peering between my CSR and the Tier 0 gateway, and then I did some redistribution between BGP and OSPF in order to get the routes to propagate. And then I went ahead and I advertised a default route from the CSRs down to the Tier 0 gateway, so there would be a default route propagated down to the Tier 0 gateway to provide us an exit point off the NSXT environment. That enables the virtual machines that are running on that overlay segment to have internet access. So I'm actually going to go show you what that looks like right now. Let me go ahead and switch screens real quick. So I'm going to log into vCenter real quick and show you what I've got going on there. And I'm going to log into NSXT Manager. And we'll be able to play with all the cool whiz-bang wow stuff. So go ahead and get all that squared away. NSX Manager's there. I'm going to go click on the networking tab here, and then I'm going to say network topology. This is going to show you kind of a network topology, if you will, of how things are working. And if we were to bring it over here, actually I can go ahead and get out of the way real quick. If I was to zoom in a little bit on this. So what I first did when we got started is I created NSXT VLAN 200 data, right? This was a way for me to transition away from the comp data port group on the compute VDS, which is what all these VMs were mapped to, right? Well, I created this segment inside of NSX, and once I did that, I created a VLAN ID for it, and then on the CSR 1000V, I went ahead and I have a sub-interface created in VLAN 200. So that's working all day. If I do a show IP DHCP bind, we can see that I've got a device that's pulling DHCP from that particular sub-interface. That's where this comes in. You can see one VM. If we were to click on that, it's telling me Linux 1 is that particular VM. Right? It's telling me which VM is actually mapped to that segment. Now, I also created two overlay segments, overlay segment 101 and NSXT overlay segment 102. And if I was to click on here, it would tell me which VMs are mapped to it. So it gives me more of a physical sense of what's going on versus a logical sense. So this is one of the cool things that comes into play. So I've got a few different virtual machines mapped to it. If I click on this guy right here, Linux 5 is there. Now, what I did is I connected these segments to a Tier 1 gateway. I called it NSX DC1 T1 for Tier 1. And then it's got one service. And there's a gateway firewall. And the gateway firewall is automatically there no matter what you do. So it's turned on, and I will show you. I talked about that in the previous video that I did, and that's located underneath the security tab. If I scroll up a little bit, you got this communication between the Tier 1 gateway and the Tier 0 gateway, which is NSX DC1 Tier 0. There's one service, again, the gateway firewall. And then we have the point-to-point /31 connection. That's what they refer to as the router link connection. This router link connection is it's automatically plumbed, so it's automatically built when you link a tier 0 and a tier 1 gateway together. So you don't need to go in like an NSXV. You don't need to create a separate logical switch. Make sure that it's tied to the appropriate transport zones, and then go and map it as an uplink on your DLR and as a downlink on your ESG. You don't need to do that anymore. It's automatically plumbed for you, which is a nice capability. And then up here at the top, we see this 10150 network. And if you come down here, I have this NSXT VLAN 50 uplink. And the reason why I called it that is because it literally is the connection that allows my tier 0 gateway to connect outbound to my out to my CSR 1000V. And the way that works is if I come over here to this guy and I click on the networking tab, on my edge I have this edge NSXT trunk uplink, and it's attached to the edge VM. And if I was to come over here to this guy and see what's connected to it, I will have, if I go to actions and I go to settings, you'll see that I have 4 NICs. I got one that's edge management, which is how I'm managing the device, and then I have 3 which are trunk uplink, right? So when this is coming in, they're technically speaking, you could have a dedicated distributed port group that could be called the overlay segment or the overlay port group, right? And then you would associate that to whatever VLAN ID you're using in your backbone for doing that connectivity. And what that would look like is if we were to go to Fabric and then Profiles, I need to find the uplink profile. Notice how the NSXT uplink profile, notice how it says VLAN 20. Well, what I would do is if I wanted to have a dedicated interface set up for that to work, I would, on the vCenter side, I would create a port group on the edge that would say VLAN 20. But I'm saying, in this case here, I want to tie it to, I said uplink trunk, or I'm sorry, trunk uplink, and I'm doing that on purpose because it's just easier to trunk all VLANs than it is just than to just associate to a single VLAN, and it just makes things easier overall. It's easier to work with. So with that being said, that's basically what I've got going on here. Now if I was to go to nodes, now mind you, all this stuff is working. I'm going to show you the demo here in just a minute. If I come down here to VCSA 1 and I expand compute 2 and I expand compute 1, you'll notice that I don't have any tunnels on host 4. Host 4 is a single host, and the reason why I did it the way that I did it is so that I'd be able to continue my ability of configuring an ESXi host with with a manual configuration where I have to go in and lay out all the details. And then there's also the one where we've got a profile attached. So this guy right here has the NSXT transport node profile attached to the cluster. So in like NSXV, you would deploy NSXT or NSXV to an entire cluster at a time. In NSXT, you can deploy NSXT on a per host basis. So if there are hosts in a cluster that you do not want to be installed with NSXT, you don't have to. You can selectively choose which host you want to actually install NSXT to, which gives it more flexibility. And you'll notice that I've got a bunch of tunnels up and running. Now if we were to click on this guy right here, that will redirect us to the connectivity here. And if I was to scroll down, you're going to see where all my tunnels connect to. Right now, they're up. So I have 10.1.2014 connects to 10.1.2017 and 18.20.21, all that good stuff. Now, if I was to click on Switch Visualization, this is going to give us a visual of what it looks like from the host node. So as you can see right here, I've got the NVDS, I've got uplink 1, uplink 2, and uplink 3. And then the TEP IP here is 10.1.20.14, right? But there's technically 3 TEPs because the way that we have it configured is, actually go ahead and bring this up a little bit. You can see that there's 3 IP addresses there. That's because for every uplink that you map to the NVDS will automatically become another IP address. So it'll basically, you're tying this VMNIC6 to uplink 1 is going to get a VTEP IP, or I should say just a TEP. You got VMNIC7 tied to uplink 2. Guess what? It's going to get an IP address as well. So you're basically pinning a TEP IP per uplink. Now, if I was to come over here to the edge transport nodes and then click on him, and go to monitor, we don't get quite the visual that we did before. And this is going to take a minute because now it's got to go pull it. But it's going to give us an idea of what we've got going on. We can see there's a number of tunnels. But as you can see, I've got my fast path Ethernet 0, 1, and 2. They are up and they are tied to, go ahead and get out of the way real quick. I didn't realize I was covering it. The edge management, or edge NSXT trunk uplink. Now again, if I wanted to, I could flip this over and be a distributed port group that would get installed on that host and be used to allow the overlay communication. But a trunk link does the same thing, right? I would prefer having a trunk link deployed versus an access port, for obvious reasons. So that's basically why I did that. Now if I come over here to tunnels, there should be a bunch of tunnels up between the transport nodes and the edge VM. And as you can see by looking at it, there are. I have a total of 17, I think? 15 tunnels. So every transport node that has a source IP address is going to be connected to this guy and working the way that it's supposed to. So you can see we've got a host 3, and you can see like this, the remote IP is just one IP. We are doing a load balance source instead of a failover order, so that's part of the reason why that's showing up the way that it does. Go ahead and close that guy out. But you can see I got 15 tunnels actively working and 2 logical routers. So now that I've shown you all this stuff and all the cool stuff that goes along with it, and in future videos I'll go into detail on how to actually set all this stuff up. But if we come back over here to this guy and we look at Linux 1 is currently sitting on, so I can just come over here and say VMs, and then I want to go hit this guy and I want to see the host. Which host are these guys sitting on? So currently we have Linux 1 is sitting on host 1, Linux 2 is host 1, Linux 3 is host 3, Linux 4 is host 2. So they're spread pretty well among the 3 hosts in this cluster. What I'm going to do is I'm going to move Linux 5 to to host 4. So I'm going to click on this guy. I'm going to right click. I'm going to go to migrate. I'm going to do a compute resource only. Next. And then I'm going to choose the clusters. I'm going to say compute 1. Well, let me move it over. Compute 2. That's weird that it wasn't showing up here in the cluster. Click on next. And we need to make sure that the overlay is there, which it is. I'm going to click on next and then finish. So after a moment or so, we should see Linux 5 move down to here. And when we do that, we come back over here to host transport nodes and we click on close this out. You'll see that right now there's no tunnel available. Well, eventually that will get changed to where there will be a tunnel available, because now we're going to have a VM sitting on a host that currently doesn't have any tunnels up, eventually will. So that'll take a couple of moments to move over. Once it moves from here to here, will be able to see what that looks like. So I'm going to pause the video for just a moment. Alright, so Linux 5 has now been put onto host 4. If I come back over here and I refresh this, after a moment or so, this communication should come online. Now if I come over here to, if I click on Linux 5, and I have the IP address of 10.1.102.15, and I launch Web Console, and I do just into a Linux 1, which is in a different cluster. I'm going to go ahead and right click on this guy and say Open Remote Console. We'll just do this. I don't have VMRC currently deployed on this box yet. That'll be something else that I work on as well. So I'm going to log in to both devices. Give that a moment. You can see that that's coming online. We come back over here. We refresh. And as you can see, nothing's really going on, which is a little concerning, right? You would think, okay, well, now there's a VM attached, so it should start to work. Well, Linux 5, if we were to come in here and do an ifconfig, and then ping 10.1.102. We can talk to it, right, which is what we want to see. And then if I was to ping, say, 10.255.1.1, that's an IP address inside of my home network. And then if I was to ping google.com, that should also work. Now if I go back over here to this guy, eventually this should get pulled up. Now if you click on this little eye or hover over it, it tells you that no virtual machines on the host are available. No virtual machines on host are in powered off state. Host is in maintenance mode. I know none of that to be true, right? We can see Linux 5 is there. It's clearly working. It just for some reason takes time for this to populate, and then once it does, then it makes more sense. I don't know why VMware chose to go the direction of having the tunnel down. To me, as somebody that has to commonly prove that the network is not the problem, what we call it the mean time to innocence, or the MTTI, I often don't like this, because now I'm like, okay, well, the control plane says one thing, but the data plane is showing something different. So if I was to, the segments aren't going to show me anything here, but the other thing I want to do here is this particular virtual machine is sitting on a VLAN backed segment, meaning that there is no overlay on this guy. So if I was to hit the up arrow a couple times, I should be able to ping something in my home local network, and then on ping outbound to the internet. I have internet accuracy, and this one here, in this particular case, is coming out of Atlanta. Last time I think we were doing it was out of Chicago. But this is one of those things where being able to understand how everything works in the back end is important. Go ahead and refresh that. And there you can see now it's got 8 tunnels, right? So it's working, right? It's just, for some reason, it just takes a little bit longer for the tunnel information to get updated inside the manager. But we can validate operations. And if I was to pull this up, I'm logged into the host right now. I'm going to go say click OK. I can log into the Edge VM and take a look at what's going on there and all that type of stuff. But just to prove to you guys that it's working the way that I say it's working, let me just go ahead and click on Firefox. And this is, click on Firefox here as well. And what I really want to do is I want to basically prove that whether I'm a VLAN back segment or a overlay segment, I can reach the internet. It doesn't matter which ones I'm attached to. So I don't know why that's not pulling up. Okay, there it goes. So this should reach out to Firefox. Oh, I was impatient. That is so common for me. Now, mind you, this is a slow process, and just to prove that it's not just a default thing happening here, I'm going to click in here and go to google.com, something I know is resolvable on the internet. And so there you go. So we know the internet's working inside of our environment. Linux 5 is on an overlay segment. Linux 1 is on a VLAN back segment, which means that NSXT is delivering the VLAN segment to vCenter, but it's an NSXT. What do they refer to it? I'm trying to think of the name. They call it. The name is escaping me at the moment. I can't think of what they call it. The name is, it's like right at the tip of my tongue. I can't even think of what they call it anymore. These are opaque. It's an opaque object that's pushed from NSX Manager down to vCenter server. So we know that's working. Everything's good to go there. Everything's good to go here. So we know we have internet access. This was a big deal for me. Actually, I ran into a problem where it wasn't working, and so one of the things that I had to go do, and I'll show you what I did real quick, just to show you. I had to go underneath the BGP process, and I had to do a default information originate, and then I had to push a default route, and then let me go ahead and log into the Edge VM real quick. And I will be showing you guys how to do all this stuff once we start the series. I'm just playing with a lot of different stuff right now. So here we are. We're going to get logical router. And if we were to go to, let me go ahead and scoot this out just a little bit. And do a VRF4 and say get forwarding. We'll see that there's a default route being propagated down via BGP. Now, this wasn't there before until I added in those couple commands, and by doing that, it allows me to push a default route from my CSR 1000V down to the tier 0 gateway, which is what I'm looking at. If I was to exit out of here and say get logical router, you can see that we have tier 0 at the bottom, these guys, right? And then we have tier 1. So technically speaking, I don't have any real services working. And if I was to go back over here to NSX and go to security and go to distributed firewall, go ahead and get out of the way real quick. To my knowledge, you're not able to get rid of this. It is not a deletable or manipulatable. Actually, see, this is one of those things where it's like default layer 3 rule is permit. So the idea of you can create a rule underneath the distributed firewall, or we like to refer to it as the DFW. Underneath the DFW, under this policy, you can create a rule, which is already right here, saying, you know what, it doesn't matter what is going on. We're going to allow the traffic anyway. So technically speaking, there's no way to disable you can't disable this rule. It's always going to be there. But I can turn this rule off and this rule off, right? That's one way of doing it. So what this basically does right here is if I wanted to allow DHCP to happen, guess what? If this was disabled, it would never get processed, right? So it would just be a default layer 3, and it would just permit anything IP. So let me go ahead and publish those changes real quick. And okay, now it's been successfully deployed. It's allowing the traffic, right? But if we go back over here to networking and we go to topology, what you would expect is the service would go away, right? And it's not going to. The service is not going to go away. And that's why the SR, right? Oops. That's why the SR shows up right here. The service router, tier 1, and the service router, tier 0. That ties to the gateway firewall in NSXT. So that's why things are the way that they are. So with that being said, that's pretty much it for what I wanted to demo with you guys today. I'm going to be playing with some more stuff and releasing some more content around NSXT in the following week or so. But if you guys have any questions or anything, please drop a comment in the comment section below. Please like, share, and subscribe. And I'll catch all you guys in the next one.